Hello, today I will talk a little bit about the Dynaco S5 ATEX door. Not only about the door itself to give some benefits and features, but also about ATEX in general. So I will explain some typical wording and terminology about ATEX. First of all, ATEX, what is it? ATEX is an explosive atmosphere. This is the sign, the logo of an ATEX zone. So the triangle in yellow. In fact, ATEX is coming from the French. It's coming from atmosphère explosive or atmosphère explosible. There is the word coming from. Why do we need classification on ATEX and why did we get regulations from the authorities? This is because in the past there were a lot of incidents and accidents. Typical incidents and accidents were coming from the oil and gas industry, of course, but also from the chemical industries. Those big incidents had, of course, a lot of casualties, and this is where the government put in place regulations to avoid accidents like that. This is where you have the regulation for the equipment used in ATEX environment. At first I have a movie on the left side of the screen that is giving you or is showing you what can happen. This is the worst scenario. So when I play this movie, you will see the extreme situation, what could happen when the rules are not followed strictly. On the right side, we have another movie, what I like to show, because this is a very a situation that is really recognizable for everybody, because we do it ourselves every week or several times a week. So the situation here is a gas station. You see the lady arriving and she wants to fill up the gas tank. We all know that in a gas tank you have, or a gas station better, you have the ATEX sign. You have also the mobile phone sign that is not allowed. I'm sure that a lot of us still sometimes use the mobile phone, but we shouldn't. But it's also an ATEX zone. This is more important. And when we follow the movie, at first it's not really clear what is going wrong. At first the lady is doing the correct things. And then a little bit later in the movie you will see that there is an explosion. And here we see the effect of this small explosion. Lucky the lady is staying very calm, but when we analyze what happened is that the lady was charging herself with static electricity, and this sparkle of the static electricity was causing the explosion. Next step is about the certification and giving you a summary of the certification of our doors. I have made it in one line, so the two detailed parts I left out. The important parts I put in one data string. As you can see, the first Roman 2 on the screen is indicating that it is a certification for an industrial situation. If it would be a Roman 1, this would indicate it's a situation or certification for a mining application. This is what we don't do, we only do the industrial applications. The next part is explaining a little bit about zones. The end customer will talk about zones. Let us start
with the gas zones. You have a zone 0, a zone 1 and a zone 2. At the left side you see the typical image of a gas station again. The tank underground is a typical zone 0. Around the pump and the nozzle it's a zone 1, and a little bit further away you have then the zone 2. The zone 0 is the most dangerous zone. The risk is the highest. Zone 1, orange, is the intermediate, the medium risk zone, and the zone 2 is the lightest version of the risk. To give you a better indication on how high or how big this risk is, a zone 2 is when you have approximately maximum 10 hours of the risk being present a year. So this is quite an acceptable risk. When you go to zone 1, the risk is there between 10 hours and 1000 hours. So the risk is getting a little bit more important. Zone 0 is more than 1000 hours risk a year. So you see the difference that gas situation, it is zone 0, 1 and zone 2. If you go to the next slide, you see that now we talk about the dust. And dust, we talk about zone 20, 21 and 22. It's the same logic as in the previous slide from the gas zones, but you put an extra number, so the zone is always 2 digits. Same logic, the zone 20 is the highest risk, zone 21 medium risk, zone 22 the lower risk. But then we are here talking about zones and we talk about categories. For me this is the most important slide because it is giving a nice view on the comparison between zone and category. On the left side you have zone 0 and 20, 0 gas, 20 dust. Zone 1, 21 and 2, 22. The zones are always used at the customer's situation. So a customer, an end user with an ATEX situation will always talk about a zone. Next to that, on the right side, we talk about category. This means a product that is certified to be used in an ATEX zone is getting allocated a category. And there you see the confusion that, for example, at the right side, a category 1 product is compared to is accepted to be used in a zone 0 and 20. So there already the first mistakes at the first steps in the first discussions with the customer are already happening. But this table is giving you a good overview on the comparison zone versus category. So in the next part of the string we see 2 GD and 3 GD. The 2 and the 3, this is for the category what our product is receiving after certification. And the G and the D stands for gas and dust. This means that it is valid for a category 2 gas and dust, and the next one is valid for a category 3 gas and dust. So this is giving a better understanding on the technical explication of the string of the certification. The next step is the 2C and the T4. This has to do with the gas groups. The gas groups you see here, 2A, 2B, 2C. These are all the different gases put in a class depending on the explosion levels, the lower explosion level, the higher explosion level, on the risk. So they have divided the different types of gas in gas groups. Then on top of it you see the different temperature classes, T1 to T6. You see in yellow the gas groups and temperature classes where our door is accepted for, where our door is certified for. This means that we can use our ATEX S5 door in the 3 gas groups, as well in 2A, 2B and 2C. And we can use it up to category T1 to T4. The temperature classes has to do with the surface temperature of our product. This means that our door, the ATEX S5 door, will never reach the surface temperature of 135 degrees, is the T4 temperature class. This means that none of the parts, so not the engine, not the gearbox, none of the parts will reach a temperature of 135. So this has to do with the explosion level of the temperature of a certain gas. For example, a certain gas will explode at 180 degrees. Our door can be used in that situation because by certification we will never reach 135 degrees, so for sure not 180 and for sure not 450 as in class T1. So if the customer requests a T5 or T6, this is open, this cannot be fulfilled with our door, but as you see, most of the temperature classes and the gas groups are covered by the door, by the certification of the door. So this you see also in the string. So we continue, the 2CT4 is explained, what it stands for. The next step is the different dust groups. Here we have the certification for 3B dust group. The different dust groups are shown as in the yellow and the red. You have coal dust, you have flyings, this is just dust in general. And then you have 3B, you have non-conductive dust. And 3C is conductive dust. This is a typical example is the dust of metal parts. You see it's in red. This means that we are covering 3A, 3B, but not 3C. So this is what is shown in the ATEX rating, I would say. Challenges of an ATEX zone. First of all, an ATEX zone is always an expensive thing because as soon as a certain area is classified as ATEX, this means that all the electronic or electrical equipment should be with certified ATEX equipment. This is from lightning bulbs or lamps, communication equipment, every electronical component used in such an area has to fulfill the ATEX regulation. So in a lot of scenarios, the easiest way is just not to have doors, so open doors. This means that there are outside working conditions. In the cheapest scenario, you have then manual operated doors. What means that your flow of goods and your working conditions is really not optimal. This is the consequence of having no doors or manual operated doors, so you will not have a really good flow of goods and personnel. The solution is a roll-up door, a high-speed door. We have two types. First of all, we have the ATEX Zone 1 and Zone 2 compatible door, what we call a Category 2. And you have the second one, it's compatible for Zone 2 and Zone 22, is the Category 3 door. The high-speed doors, the ATEX S5 doors, are pre-assembled and they are having a unique certificate by an inspected certificate given or provided by a European official notified body. By using such a door, you create a continuous flow of your goods and your personnel. This also means that your working conditions are getting much better because you are having closed doors. The contamination of your ATEX zone is also much smaller because you keep your contamination or your risk inside. And you can go down with your ATEX related costs because you can in some scenarios use partitioning. This is giving a good example in the next slide. You see at the left side here an ATEX zone. For example, this is now 1,000 square meters. When using an ATEX door, certified ATEX door, in this situation you can go down with your ATEX zone, for example, from 1,000 square meters to 500 square meters, what is giving a big impact to reduce your costs in electricity and electronical equipment needed in the ATEX zone. It's also then increasing the safety because your people and your personnel can continue to have an easier flow in the non-ATEX zone, but still a good accessibility to the ATEX zone in a safe way. With the ATEX doors, you have an easy access to explosion-sensitive zones. Important to know is, you see it on top of the slide, is that our door is conform the Directive 2014/34 EU. This is the latest directive. So this is the directive that is now in place since 2016. So the door is fulfilling the latest requirements of legislation. The Dynaco S5 ATEX door assures the maximum safety because, let me explain, the complete door is composed of materials suitable to be used in explosion-sensitive environments. You see on the slide a lot of AX logos. This is just to indicate that all the parts have been chosen and selected to be safe or accepted in an ATEX zone. Again, here it's showing that all the parts have been inspected and selected. All the parts have been, or they have their own certificate. For example, the engine has a certificate, the photocells, the gearbox, but also then, for example, the curtain is a special selected curtain with carbon inside to avoid building up static electricity. Way of speaking, all the parts have been tested. We have done also impact tests. This has been done together with an official body that is allowed to do product and type certifications. In this case, it is Apragas. That is comparable to, for example, Apragas is a Belgian institute that is European accepted, is an official body. You can compare it to the German TÜV Süd or to the Dutch DEKRA, but okay, every European country has his own official notified bodies. So the result is, in fact, the outcome is, this is, again, we already talked about this, the two doors that we have as a finished product is the category 2, again for zone 1 and 21, and the category 3 door for zone 2 and 22. Some of the special features of the S5 ATEX door. The people who know our product range, the S5 ATEX door is based on an M2. We have the 3 different versions as in the M2. So we have always the compact, the power and the all-weather. This is depending on wind capacity that they can have. So this means that we have an indoor or an outdoor application. The metal parts are all stainless steel. In one of the next slides, a little bit more about this. There are no painted parts possible. Let me explain why. If you paint the metal parts, in this case the stainless steel parts, you have to be able to provide an exact thickness everywhere. We have no possibility to have an exact thickness of the paint, so this is the reason that we keep them without paint. All the non-metallic parts bigger than 20 square centimeter are replaced by anti-static materials or electrical conductive materials. This to avoid building up static energy. The speed is also limited to 1 meter per second, going up and going down, or closing. Why this 1 meter per second? 1 meter per second is kind of magic number in the ATEX world. Everything below 1 meter per second is not fast enough to build up static energy. So here a small view on the structure. So what parts have been adapted? So for example, the pulley wheel is a special anti-static material. Covers, all the covers are only available in stainless steel. You have on both sides, left and right, you have your earthing kit. Important part that if there is anyhow built up some energy, static energy, that it is possible to guide it away through the earthing kit. The gear wheels, completely stainless steel. The bearings are stainless steel. The complete drums are stainless steel. So, as mentioned, the complete structure is all in stainless steel. The guiding parts, all the guiding parts are in black anti-static material. You have also installed discharge brushes, so left side, right side on the two drums, so 4 discharge brushes. This to, in case that there is building up some static energy that is guided away through the brushes and to the earthing kit. Sealing flap and roll-up strip are electrical conductive or anti-static materials. The roll-up strip is a silicone rubber and the sealing flap is an anti-static, same as the curtain itself. The teeth, they look the same as the M2, but they are also in a different material, in an anti-static material. Also the steel cable is and the screws are stainless steel. A big difference here, all our Dynaco doors, the WDD, is always wireless, but wireless is not compatible in ATEX environment. This is why the WDD is again with a spiral cable. Some small changes on the finishing of the bottom back, but in general it's pretty much the same as our standard doors. The driving system. So the ATEX, it's an ATEX motor, it's an ATEX gearbox. The encoder for the category 3, because we are now on the slide of category 3 ATEX. The encoder is the DNC as we know it, but with a special housing. Also one big difference is the silent blocks where the engine is mounted, also in a special conductive silicone rubber. So of course we always need a control box next to the door. In the case of the category 3 door, we have the possibility of a Dynalogic 2 or Dynalogic 5 control box. The control box is always to be installed outside the ATEX zone, can never be in the ATEX zone itself. The main difference here in the control box, you see the blue parts. This is for the intrinsic safe circuits. This means in this case you have 2 cables from the photocell, 1 blue cable from the WDD, and they are called intrinsic safe, and they always have to be in cable ducts that are blue to separate from the normal cabling. The next slide is the category 2 version of the door. The difference is, there is only one difference, it's the encoder. The encoder is not our standard DNC2. This is a complete different ATEX certified encoder. And this is the reason also that for the category 2 we can only use the Dynalogic 5, because the communication, the protocol of the encoder is different, and therefore we need the Dynalogic 5. Here again you see the blue wires are the intrinsic safe circuits, again of the photocells and the WDD. anti-static, because we have been talking a lot about anti-static materials, etc. We all know, especially in winter time, that sometimes we get some electricity when we shake hands or when we open our car. This small sparkle is in fact static electricity, but that where from the small particle with a very high, or the energy can be very high, can be high enough to make something explode. Important here is that we stay below 1 gigaohm, where we are much lower with the complete door when all the tests are done. But this is also magic number is 1 gigaohm. Everything below is okay, is accepted. As mentioned, the complete door is in, or the complete structure of the door is in stainless steel. Why stainless steel? In fact, we could use normal steel if the rate, or if the magnesium inside the steel is less than 7.5%, then it could be accepted that you use normal steel. None of our suppliers is able to confirm to us or to put on paper that there is less than 7.5% magnesium, and this is why we choose the safest, that we did the safest choice and used complete structure in stainless steel. The speed limit, why the speed limit of 1 meter per second? This is also, I think, quite clear. When you stay below 1 meter per second, it's too slow to build up static electricity. This is why opening and closing is 1 meter per second. The certification of the door. Every door is receiving a complete certification. We have 2 type certifications, one for the category 3 and one for the category 2. In practical, every single door is pre-mounted at our facilities and is inspected and checked by the European notified body. In this case, this is Apragas. The certificate is on the serial number of the door. So this means that each door, each serial number is receiving a unique certificate. This is giving a complete peace of mind, because this means that you have done everything within your power to be as safe as possible in your ATEX environment. This has especially to do with responsibility in case of an incident. Then we come to some benefits. Of course, the safety of the door. This is in fact not related especially to the ATEX part of the door, but this is related in general to our Dynaco high-speed doors. It's safety for people and goods because we have no rigid elements. When you compare it to the competitors, they sometimes have rigid elements that can injure people. The complete curtain is flexible. We are working with a soft bottom with bottom edge detection and a photocell, so as safe as possible. We have a very smooth operation because of our unique technology. This is a push-pull technology. This means that we are pushing with the engine the door down and also pulling with the engine the door up. All our doors have a frequency-driven motor, and they have also an encoder. So the door is always controlled in a correct way, and it's always in the correct position because of those items. Another benefit is, of course, the uninterrupted workflow, because the doors are accident forgiving. In case that there is an accident, the door is self-reinserting. It has a unique zipper that is flexible, but important is that there is no downtime if there is an accident or an incident. Some of the possible applications, because we talked now a little bit about ATEX, but also, okay, we need to know where can we sell this door. The typical applications or industries that everybody is thinking of is the chemical industry and the petrochemical industry. Yes, this is correct, but there is much more where our door can be an extra value. Can be on ships, but for certain also the pharmaceutical industry. They have also in a lot of cases ATEX environment. Silos, then I think more on grain silos. This is also can be quite explosive, the dust of the grain. A very important potential market is the food industry in general. Food industry, think of milk powder, so the chocolate powder, the industrial bakeries, you have flour, you have sugar refineries. These all items that are explosive. The dust is explosive, so can be an important market to promote the doors. And of course also the wood industry and industrial painting and spraying booths are a big potential for our ATEX doors. So this is giving you a good idea on the possibilities of the doors, but also giving you an indication on some typical wording and situations of ATEX. I hope that this makes things a little bit more clear. This was the complete presentation. Thank you for the attention.